Hi guys, so in this video we're going to talk about the different states of matter that you can see on the periodic table. You'll need your notes, your reference table, as well as a small periodic table to put into your notes. We're going to talk about solids, liquids, and gases. So first, let's talk about where they're all located. The nice thing is that for liquids, there's only 3 elements that are liquid, only 2 that the Regents asks you about. Mercury, gallium, and bromine. So mercury and bromine are the 2 that they typically ask you about, but gallium is also a liquid, close to room temperature as well. So for gases, there are a few more that are gases, so I do want you to take a look on here. The thing is, though, I want you to remember the number 17, all right? So the element number 1, which is hydrogen, that's a gas. Go over to element number 7, nitrogen, that's a gas. And from there, make the number 7. All right, so you can see that I'm making the number 7, so across and down, those are all going to be gases as well as element number 17. So the number 17 is really important for gases, just to help you, it's a nice way to help you remember. Again, element number 1, hydrogen, element number 7, nitrogen, and from element number 7 or nitrogen, make another 7. Those are all going to be gases, as well as element number 17, which is chlorine. That's a gas as well. If you notice, there's only one here that isn't shown, that's He, helium. That doesn't fit into our 17 little way of remembering, but that's okay. That's still another gas as well. Everything else that's not a solid or excuse me, that's not a gas or a liquid will be a solid. So all of those transition metals over here, except for of course mercury, the lanthanides, the actinides, group 1 and 2, and all of these other guys over here as well. Those are all going to be solids. So let's talk about the properties of solids. First of all, if you notice in the particle diagram, the particles are really, really close together. They do have a definite shape, meaning that even if you take that solid out of that container, that will still be the same shape. It cannot be compressed, meaning you can't bring it or kind of push those particles down together any further. They have strong intermolecular forces. So intermolecular forces, I abbreviate this as IMF. So IMF, we'll talk about these a lot later on. Those are pretty much the forces between the 2 particles that are next to one another. So if we take this particle and that particle, they have really strong forces of attraction between each other. It's kind of hard to separate them out. So think about you and your best friend. Really high forces of attraction between you guys. Again, really hard to separate you guys. If I made you two move, that probably wouldn't work out very well. Also, these solids do vibrate a little bit. The particles vibrate slightly. So you notice that they're like a teal color, and then the little red part shows you the vibrational movement in there. Liquids, again, your mercury, gallium, and bromine, they have no definite shape, meaning that if you took this out of the container, it would kind of spill all over the place. So these take the shape of the bottom of the container. They are difficult to compress, but not impossible. They have weak intermolecular forces with one another, and they slide around really easily. You can easily break these forces of attraction between one another. Gases, on the other hand, have no fixed shape. So if you opened up the container, the gas particles would go everywhere. They spread apart completely to fill a container. They can be compressed, meaning you can push them towards one another. They have very little intermolecular forces, meaning that they're not going to be stuck with one another. They're going to be spread all throughout the container. And they have a lot of energy when they do that. And they're constantly moving. So if you look at the gas particles here, you see that they all have arrows attached to them. That's showing that those particles are constantly moving. Don't forget to use the rule of 17 to help you figure out which ones the gases are. So to summarize, if you want to figure out what the gases are, use the rule of 17. Start with element 1, which is hydrogen. Go over number 7, which is nitrogen. Make a 7. Those are all gases, as well as element number 17, chlorine. The only thing that doesn't fit in there is helium. And these particles are spread apart a lot, and they move around constantly. Liquids are gallium, bromine, and mercury. Bromine and mercury are the 2 that are heavily tested on the reagents. And solids are pretty much going to be every other element. Have a great day, guys.